سلام علیکم. سلام علیکم و رحمت الله. I hope you are well. This is the next session. This is the another session of advanced database. Okay, and in this session, I'm going to talk about the leaderless replication. Is there any candidate to translate my the English language to the Arabic? Anybody can translate from English to Arabic for your classmate? Is there any candidate? No? Okay. Okay, so this is the only choice for me that in this class I'm going to talk in English, and okay, I hope you are understanding that something that I say. Okay. Alaikum assalam, Zia. Okay. Before this class, I talk about before this session I talk about the two types of replication: single leader replication and multi-leader replication. And today I want to talk about another type of replication, which is a leaderless replication. Okay, so what is the leaderless replication? In this type of replication, we don't have the leader, and you know, in two previous types, some machines some machines were followers, and some other machines were leaders. Okay, but in this type of replication, we don't have the leader, and so the role of all matching as the same as each other, and the concept of leader is abundant in leaderless replication. In this type of replication, any replica can directly accept write from clients. Okay, so the write request from the clients can send to any replica, and the replica can accept write which is received from the clients. Okay, so there are some advantages and some disadvantages for using this type of replication. I'm going to talk about them. Okay, this technique mostly famous for Amazon in Amazon company. This technique is used is introduced as dynamo system or dynamo style, which are used in some databases such as React, Cassandra, and Voldemort. React and Cassandra is most famous, and they implements this and use the dynamo style and leaderless replication. In this type of technique, in this type of replication, there is no particular ordering of writes, and this is a challenge. And so I'm going to say yes, I'm going to talk about this challenge. Okay, what to do when node is down in leaderless replication? Okay, I'm going to answer this question, but before that, it's necessary to understand what processes are done in this technique. In leaderless configuration, we have not any leader, and I say you that the role of all matchings are the same. So when we have not the leader, okay, so there is no the failover process does not exist. The failover process does not exist, because the failover is related to the leader, and when we have not any leader, okay, so the failover process does not exist in this technique. In leaderless replication, a quorum is required. Okay, I'm going to talk about this technique. By using this figure, I can describe this technique and show some features, some characteristics of leaderless replication. In this example, you can see the user 1234 wants to write something. When we have leader, we know that the write request must send to leader matchings. But in this technique, we have not any leader. Okay, so the write request from the user should send to all replica. You can see there are 3 replica, and this request is sent from the user 1234 to all replicas 1, 2, and 3. The replica 1 and 2 receive this request from the user 1234, and so they confirm this replica confirm the write request and send the OK to user 1234. But the replica 3 is offline, and it cannot receive this request, and so the replica, the user 1234 does not receive the OK from the replica 3. In this example, there are 3 replicas, and 2 replicas accept the write request. Again, in this example, there are 2 replicas, and 2 replicas accept the request. It's enough, because because the more replicas accept the request. Okay, it's enough. It's enough. When the more replicas accept the request, that's enough for the user. And we need durability. We need durability in database. Okay. So this request, which is sent from the user, is confirmed, and all replicas should have this record this data. Okay, what's happened for the replica 3? After some times, the user 2345, does the user know how many replicas there are? Yes, Nazar, yes. It's necessary for you in this technique. It's necessary that the matching of the user's matching need to know the number of replicas. When the user send the order, the order is not important in this technique. I'm going to talk about the order, and there is no order in the information, in the data. I'm going to talk about it. Okay, after some time, the user 2345 wants to get the latest information, the information which is stored for the value me-new.jpg. You can see the user 2345 send the read request. This request should send to all replicas. We can compare the leaderless with the 2 previous type, leader and single leader and multi-leader in some aspects. In single leader, the write request should send only to the leader, and the read request should send to only one replica. But in this technique, in leaderless technique, the write request should send to all matchings. Not one matchings, such as leader. And also, again, the read request should send to all matches again. Okay, so this query is sent from user 2345 to replica 1, 2, and 3, and the user 2345 wants to get the picture of the user 1234. Okay, so this request is sent to all 3 replicas, and the replica 1, replica 2 send the latest version. The latest version is version 7. For the image of user 1234. Okay, so the replica 1 and 2, which receive the latest image from the 12345, send the latest version which is 7 to the user 2, 3, 4, 5, but the replica 3, which does not receive the latest information from the user 1, 2, 3, 4. Okay, so the previous version is sent to the replica, is sent to the user 2, 3, 4, 5. Okay, please see this information. The value me-all.jpg, the version 6, and in these two messages you can see the value is me-new.jpg, which version is 7. The user 2, 3, 4, 5 compare the data, and it can find the latest version is 7, and me-new is the latest image which is uploaded by user 1, 2, 3, 4. Okay, so this user prepare, create a message, and this message is sent to the replica 3, and user 2, 3, 4, 5 send a message to replica 3 to let it know the image is updated, and the latest version is version 7, and the latest image is me-new.jpg, not me-old.jpg. Okay, so we can see after sometimes, and the replica 3, such as others replicas, can get the latest information and update its information. Okay, is it clear? In this technique, we need quorum. Quorum for write and quorum for read, which is called quorum write and quorum read. And in this example, the quorum for write and read is 2, because the number of replicas is 3, and we want to get the latest information, and so when the number of replica which received the latest information is 2, okay, that's enough for us, because more replicas receive the latest information. It's called quorum for quorum write and quorum read, and we need quorum in leaderless replication. You can see the eventual consistency happens after some times by using the read repair. The read repair is a process which I talk about it in the previous example. In this example, it's called the read repair, and read repair can cause eventual consistency for all matchings. Read repair used to update old value by the reader. Yes, the role of this user is reader, and the role of this user is writer, and the user 2, 3, 4, 5 as a reader update old value. Okay. And this technique works well for the values that are frequently used. Works well for the values that are frequently used. It means in this example, the user 2345 wants to see the image of 1234. This data is required for this user. Okay, so this user can understand that the node the replica tree has not the latest version, so it send a message for replica tree to update its information. But some information is not some information, some values are not frequently used, frequently used. So it's a problem for this, is a challenge for these values, because we need consistency, and it happens for the values that are frequently used, but it not happen for sometimes for the values which are not used by other by the readers. Okay, so one technique is presented for this challenge, which is called Anti-Entropy Process, The Omar asks, okay, say the updated value from one node and the old value from another node, the version number is used to determine the updated value. Yes, Omar, it's right. Yes, thank you. The updated value, yes, the version is used. The version number is used to determine the updated value. Yes. Okay, so I talk about some values which are not frequently used. So the reader, so these values can be different in some matchings, and we know another process which solve this challenge. The anti-entropy process is introduced for this challenge. Okay, please let me for 1 or 2 minutes. After that, I will continue. Okay, so let me. I'm sorry. Okay, I want to talk about the anti-entropy process. Anti-entropy process is a background process that constantly looks for difference between replicas. I say you for the data, for the values which are not frequency use, okay, these values can be different between replicas. Okay, the anti-entropy process is it can be a process. It's a background process that constantly looks for difference between replicas. Okay, it can find, this process can find the difference between replicas. Okay, and it can be used to change the old value to the new value. But there is a significant delay in this process because this is a heavy process, heavy load process, and it can decrease the performance, and also there is a significant delay to update the values, the old values. And also another challenge for this process is we know that all system currently does not have an anti-entropy process because it's a heavy process. It's a special process that need to compare the data between the replicas. So this technique is not so interesting for many advanced databases. What do you mean entropy? Entropy process entropy is a process, is I can say I can say entropy check the relation between the data, check the dependency between data, and it use some logarithmic measure. In the definition, the entropy is a logarithmic measure of the rate of transfer of information, in particular message or language. Usually, I can say in computer and in the when we have some data, the entropy is a operator that compute, that measure the relation between data. That yes, it can be used. This is it's the name, but you can talk about yes, is a check process. Okay, now I'm going to talk about this figure. This figure show there is one writer and one reader. I'm going to talk about the quorum now. I say that we need quorum write and quorum read. In this example, you can see 5 replicas. Replica 1 to replica 5, and the writer sent the request for all replica, and you can see 3 of 5 replica receive the request from the writer and confirm the request, but 2 other replicas, which is replica 4 and 5, don't receive the request from the writer. Okay, so these two replicas have the old value and in these three replicas has the new value. I'm sorry. I'm so sorry. Okay, so the W is 3. The W is 3, and so I can say the 3 of 5 replica accept the write request. So the successful write is 3. The 3 of 5 is acceptable for us. Okay, so this request is acceptable. In another side, you can see there is a leader. The leader wants to get the information, get the data. Also, the get request is sent from the reader to all 5 replicas. And again, the 2 replicas, which are the replica 1 and 2, don't get this request, and these 3 replicas get the request and response the request. So the reader get the value from these 3 replicas: replica 3, replica 4, and replica 5. We know the replica 4 and 5 have the old version, but the replica 3 has the latest version, the new version of the value. Again, we can check the quorum. We can see the 3 of 5, the 3 of 5 replicas answer this response, this request to the reader. Okay, that's enough, because the 3 of 5 replicas answer this request. So the successful reads is 3 and 3 of 5, and the quorum read is I can say the more replicas response these requests. Is a rule: if W plus R, the successful write plus the successful read, is more than the number of replica, is more than the number of replica, at least one of the R replica, you read from must have seen the most recent successful write. Yes, again, must have seen the most recent successful write. Okay, in this example, we can see the replica 3. The replica 3 has seen the most recent successful write. Yes. Okay, so in this example, we can see by using this simple equation, the W plus R is greater than N. N is the number of replica, and W successful write plus successful reads. Okay, so at least one of the R replicas you read from must have seen the most recent successful write. Okay, is clear for you? Is it clear? Thanks, Nazar, and Hassan. Thank you. What's happened for other students? Can you get it? Ibrahim, Ahmad, Amjad, Yasim. What's your idea? Can you get it? These 5 atoms, one of which must be unique. These 5 atoms, one of which must be unique, unlike the others. Reading and writing. Today I did not understand anything from the session because of the internet, Muhammad Jafar wrote. In this case, the replicas that contain the old value are modified. Yes, Nazar, yes. And Hassan said that the internet very bad today. Okay, I'm going to talk about these concepts clear with some examples. Okay, so I expect that you understand something that I say and you ask your question. Okay, so inshallah you have a better internet connection as soon, inshallah. Okay, and some question. The Nazar ask, yes, Nazar, but I'm going to talk about the quorum and quorum for write and read, quorum write and read, and when we can be sure that one of the replica, at least one of the replica must have seen the most recent successful write. Okay, in this example, we concentrate on this question and on this challenge. And I say that when we use this query, we know we can be sure that at least one of the replica must have seen the most recent successful write. Okay, quorum for reading and writing, quorum for reading and writing. If there are n replicas, every write must be confirmed by doubling nodes. If there are n replicas, every write must confirm by doubling nodes to be considered successful. Yes, the W is the quorum write. We know. And as long as W plus R is greater than n, we expect to get an up-to-date value when reading. These sentences is about we can get and we know these sentences are right because in this example we can get this sentence is right, and reads and writes that obey and these R and W value are called quorum read and write. Yes, R and W values are called quorum reads and quorum writes. We know that. And we know the R and W values are the minimum number of votes. Okay, so a common choice is to make n an odd number and set W and R to n plus 1 divide 2, round up. Okay, rounded up. But we need to round it up. For example, in this example, we have 5 replicas. Okay, so we want to calculate the quorum reads and quorum writes. Okay, so we can add this value, the number of replica plus 1, 5 plus I'm going to talk about how we can calculate the W and R. The one good method which is introduced to calculate the quorum read and quorum write is it. We can increase the number of replica. Okay, so in this example we can n plus 1 which is 5 plus 1 is 6, and so the W is equal, the R is equal to 6 divide 2 is 3. Okay, so by using this technique we can and Nazar wrote that n plus 1 plus 2. Yes, in this case, yes. If the number of replica instead of 5 is equal to 4, for example, if we have 4 replicas, again, when we want to calculate the quorum read and write, again we must choose this query. 4 plus 5, 4 plus 1 is equal to 5, and after that we need to round up 5 divide 2, we know it's equal to 2.5. Okay, and so again when we have 4 replicas, again the W and R is equal to 3 again. So because we need to round up, and so in this example the round up 5 divide 2 is equal to 3. Yes. Mohammed Jafar asked, why 2? Divide, why 2 is good from what, Mohammed? Is it the result of subtracting, writing, and reading from each other? 2. Nazar, can you answer the Muhammad the question from Muhammad? Please read the question from the Muhammad, and after that please talk about your question. His question, sorry. No, Muhammad, no. If you talk about the number of two, when it's constant, because we want to talk about the two operation, two process, to read and write, and we want to have at least one replica which have seen the most recent successful write. Thank you, Omar. Thank you. Thank you, Nazar. Thank you. Okay, Muhammad. Thank you, Nazar. Another question. How about setting W equal n and r equal 1? We know by using this value, we know that this equation is right, and again, please check and please consider this question. We are going to set W n and r 1. We know W plus 1 is greater than n. W plus 1 is greater than 1. Why? Because the W is n. Okay, so n plus 1 is greater than n, and we know in this situation at least one of the replicas most have seen the most recent successful write. We know, yes, Great. Nazar and Muhammad talk about the previous situation, the previous question, and I'm waiting to for them. No, I'm in class. Nazar and Muhammad, you can talk in. You can use your microphone. Okay. I'm going to talk about another question. If you are ready, okay, I can talk about this question. by I need your concentration. Okay, Mohammed and Nazar, are you ready for another question? Okay, thank you. I'm going to talk about this question. How about setting W is equal to N and R equal 1? We know by in this relation is right because W is N and R is 1. N plus 1 is greater than N, and it's possible is acceptable. But what is the challenge of this state, of this setting? We know when the W is equal to N, is equal N. Okay, in this state, when a write request is sent from any writer from all replicas should confirm the write, because the W quorum is N. So in this state, all replicas should get the write request and accept and confirm the write request. It's not a simple state. It's not because you know this is a network, and it's possible in many times that the connection is cut off, or sometimes the matching can be down. One matching can be down, and in this state we need the confirmation from all replicas. So this is a hard limitation. This is a hard limitation. But this set is very good for readers, because the quorum read is 1, and the reader can get only from 1 matchings. That's enough for readers, because in this state all matchings have the latest version. In this state, all matchings have the latest version. This makes reads faster, but has the disadvantage that just one fail node for the writers, okay, it cause all database writes to fail. That's enough. The limitation for quorum consistency. The sets of nodes used by the read and write operations overlap it in at least one node. Because of this limitation, we need to use W plus R greater than N. Okay, so because we need to have overlap in at least one node between the writer and reader. So we need the overlap in at least one node. So we use the W plus N, the W plus R is greater than N. But if W plus 1 is lower or equal than N, okay, it's possible that there is not any overlap node. It's possible when the W plus 1 is lower or equal than N. Yes, in this state, it's possible that we have not any overlap nodes for some queries. Read and writes will still be sent to N nodes, but the smaller number of successful responses is required for the operation to success. In this state, some values can be stalled. and is possible for the reader that get the solve values or read the solve values, because this relation W plus R is lower than n, lower equal than n. It's possible, not in all state, in all situation, in all cases. No, not in all cases, but it's possible to have some cases that there is no overlapping between the nodes in writing and in reading. This relation is good to have systems with lower latency and higher availability, but again, I must say in this state there are some cases that the reader get the stall values, not the newest and up-to-date values. Is it clear? Is it clear for you? Okay, thank you, Mustafa. Thank you. We can have a break time for 5 minutes, students. Please, we can have a yes 5. We can have a 5 minutes for break time for rest. Inshallah, after that, I will continue this slide and this concept. Muhammad Jafar, I'm going to talk about the monitor install nets, and okay, I'm going to talk about this question, but not completely, but shortly, inshallah. مثلا دو کلاس دارم ما بعد بلافاصله که کلاس ها تموم میشه حرکت کنیم بریم. هیچی نمونه باز اومده 20 دقیقه نشه مثلا نیم ساعت من هیچ استراحت نداشتم یه من فقط قرصامو خوردم این داره برم اونم خوردم فقط دیگه تموم بشه یه باش Assalamu alaikum. Okay, I'm going to talk about the monitoring stillness. Yes, we know that the stall get the stall values can be occur when we use the previous relation. W plus R is lower or greater than N. It's possible that in some cases the stall value received by the readers. Okay, so we need to monitor stallness and we need to monitor whether the database return up-to-date result. I talk about the anti-entropy process. Anti-entropy process is a background process that check to find the different values between the replicas. In another aspect, we can talk about monitoring stillness and monitor whether the database return up-to-date result. For leader-based replication, it's possible to compare position in replication log. We know in this type of replication, the leader should confirm the write request, okay, and we know the leader is responsible to write the chains in replication log, and so it's possible for each replicas to compare position in the replication log and find the stall values. But in leaderless replication, there is no fixed order in which the write or apply. Yes, because in the replication logs, for each request, you can see the position of the request, and so there is an order. There is a fixed order between the requests which are sent to the leader, and leader confirm them. This order is get from the position of each request in replication log. But in leaderless replication, there is no fixed order because we have not replication log, and so we cannot find the order of the requests which are sent from different writers. Okay, so in which the writes, okay, so we need to monitor the stallness. The stall, don't forget, the stall value is the old value, is the values which are not up to date. Okay, so we need to use some process which include a stallness measurement in the standard set of metrics for database. Sloppy quorums. This is another concept. Before talking about the order and how to find the order of writes, I'm going to talk about the sloppy quorums. In a distributed database, we need to use the network as the infrastructure of modern or distributed database. And a network interruption can easily cut off a client from the number of database nodes. Yes, a network interruption can easily cut off a client from the number of database nodes. This is a simple. Let me to draw a figure to talk about. After that, inshallah, I'm going to talk about this. This concept. Please let me to stop and share a whiteboard, and yes, we can have some matchings. This is the connection between each two machines. Okay, in this network infrastructure, we can see eight replicas which are connected to each other, and in this example, I'm going to write the value for W and R. I'm going to round up the 8 plus 1 divide 2, which is equal to okay. In this example, the value for write quorum and read quorum is equal to round up 8 plus 1. 8 is the number of replicas, plus 1 divide 2, which is equal 4.5, and okay, so the W and R is equal 5. We know that, yes, it's a simple equation. And when the connection between these two matchings is cut off, the connection between these two matchings is cut off. So in this case, we know every write or read request which are sent from the readers or writer, please let me again. any write request from the reader or writer can send to only 4 the matchings, not 5 matches. Yes, because the connection between them is cut off. So so none of read or write requests can become fair. In other sentence, I can say the write request and the read request cannot become fair in this state, because we need at least 5 acceptation to confirm a write or read request, and in this state, in this case, which the connection between these two matches is cut off, at most 5 nodes or 5 replicas can get the request from the reader or writer, and so we cannot accept any write or read request. Is it clear for you? Can you understand this case? Okay, the sloppy quorum talk about this case. When we cannot accept any write or read request because of this state, because the connection between some replicas is cut off, and we cannot confirm any write or read request. Okay, so I can stop. The whiteboard and share again the document. In this case, a network interruption can easily cut off a client from the number of database nodes fewer than W or R. In a large cluster, there could be trade-off. In a large cluster, there could be a trade-off. We accept write anyway and write them to some nodes that are reachable but are not among the nodes which the value usually leaves. This is known as a sloppy quorum. Still write W and R successful respond. Can you repeat the last word in the important point? Yes, Muhammad, inshallah. Okay, we can come back to the figure that I draw it. Stop and share again. Share whiteboard. I say you that the connection between these two matching is cut off, and we know that in this state we need the W and r equal phi, but unfortunately in this state the number of matching which the number of matching that can accept the read or write request, it's not difference between the read and write request, is at most 5 nodes. In a sloppy quorum, in this state, some other matchings can be used. Okay, I'm going to use some other matchings. In sloppy quorums, in this state, some matchings, some other matchings for our problems, for this problem. Again, we know that these three matchings, which I determine them, have not the value of our databases, or I can say, for example, the square figure, for example, the square figures have the partition 1 of data. All square nodes have the partition 1 of data, and the circle nodes have the partition 2 of data, for example. And we know when the reader or writer wants to read or write any request in partition 1 data, they must send the request to a square figure, to a square node. In this case, the connection between these two matches is cut off, and so any write or read request which send to the square node cannot be confirmed because we need the W phi, but the W read is lower than phi. In this state, this request can be sent to both partition, to a square node and to circle node. We know that the data in circle and square nodes are different. We know that, but we need quorum. We need quorum for write and read, and we cannot get the quorum. So before repairing this connection, this problem, in the request for the partition 1, or in the other sentence, the request for square nodes sent to circle nodes also. So in this state, we can get the W phi because the request is sent to these 4 and these 3 nodes. The number of nodes is 7, and after repairing this connection, okay, the data should send from the circle node to the nodes which are in the another part of the network. I know that. Can you get it? Can you understand what is the slopy quorum? In a slopy quorum, we use some other matchings for helping us to get the write or read quorum. When we can use some matchings fewer than the right quorum. Okay, we need to choose other matchings to obtain this limitation. And okay, can you get it? Can you understand? Thank you, Nazar. Nazar say that it's clear for Nazar. I hope that is clear for all the students, inshallah. Okay, we can come back to the Muhammad, this means that because we require the W and R successful response, so we use another matchings, which these matching have not the same information that we need them, but we use them because we need we require the special value for right request, and the right quorum, for example, is W. And by this technique we can increase the number of matchings for sometimes that that the connection is repaired. Thank you. That's enough for a sloppy quorum. This quorum is not a quorum at all in traditional sense, but it is assurance of durability, and it's optional in all common Dynamo implementation. Dynamo, which is used in React, Cassandra, and Voldemort. It's enabled by default in React, but it's disabled by default, and we can enable the sloppy quorum in Cassandra and Voldemort. Okay, and so I know that the time is over, and I cannot talk about the detecting concurrent write today. Okay, so inshallah in the next session I'll talk about the detecting concurrent write. Thank you, all the students. Thank you for participating, for cooperation. If you have not any question, we can finish the class now. You're welcome, Nazar. You're welcome, Muhammad. Have a good day. Bye for now. You're welcome, Muhammad Omar. You're welcome. You're welcome, Mustafa, Awesome, and all the students. Bye for now.